log rules. So we have log 3 has 3 rules. I think we wrote them at some point in time. Let me write them again. So in any base, I'm not going to put any base right now, but this is valid for any base. So let's say base 10, log. So if we have x times y, this is log x plus log y. If we have a ratio, we have the difference. Exactly the same thing, but the difference. And if we have log of x to the a power, then we have a times natural log, common log x. And then we simplify this if it's possible. So these are the properties of logs. There are other minor properties, like for example, natural log or log in any base of 1 is 0, log in natural log of base e, or log of a log in any base of the log of the base is 1. So I may have confused you, so let me write that. So log in any base of the base is 1. That's why natural log e is 1. Because the base of natural log is e. We just don't write it. Good, very good questions. Anything else? Anything else? Okay, in that case, I'd like to continue. We are down to 8 meetings. So 8 meetings left. I still have chapter 4 to finish, chapter 5 and chapter 6. And I also want to, I don't like to present anything new the last week of classes in which we only review for the final. So there is plenty of time, but the material is getting a little bit more complicated. So I just would like to be able to finish on time. Okay, so you can always stop me, and if you think that there is anything we have to go back to, you should always say so. Okay, so the next section, which is 4.4, we have 2 more sections in this chapter 4. So 4.4 deals with some properties. Properties of the definite. So we are going back to the definite integral. And there are several properties. We've used them already. I didn't mention them to you yet, but we used them. So a few minutes ago we had an integral, let's say from a to b, if you remember from, I'm just making one up, 2x plus 1 over 3x dx, right? So we separated the integral from a to b, we separate into 2x over 3x plus 1 over 3x dx. So what I did was I calculated the integral from this and then the integral from that. So I didn't tell you that's what we were doing. So the property is this. The integral from a to b from f of x plus g of x, a sum of 2 functions. This is it. Function, another function. dx is the same with the integral from a to b from f of x dx plus the integral from a to b from g of x dx. No, we shouldn't say that this is a distributive law. I'm distributing the integral to these two, but pretty much that's how it looks like, but it's not. This is a property. Of course, if I have subtraction here, I also have subtraction here. That's why I use a different color. So for the blue is when I have a subtraction. Same thing. So both are the same. The other property that we used, and we talked about it, is the integral from a to b from a constant times a function dx. Remember, the integral symbol and dx have to go together. So the constant goes in front. So see the integral from a to b from f of x dx. This one we used several times. The other important, which page? I think I'm on 4. Yes, I'm on 4. The other, it's not a property, it's a definition, is the average value of a continuous function. So the average value on a particular interval, of course, on a comma b. So the average value is 1 divided by b minus a, the integral from a to b, f of x dx. We're going to practice that right now. So on page 412, let's start working on different situations. There is a lot of work here because we're going to also look at areas between or even among different curves. So I would like to start with problem 4 on 412. Should I show it in the book? Should I share my screen? Where is my book? Here it is. Sorry guys, I have to move you. Okay, I have to move this too. And I want page 412. Where's my keyboard? Oh. 412. Okay. Okay, so here is the function. We are asked to find the area under the graph of f of the graph of g, function g, over negative 2 to 3. So this is the function. We do not have to graph it, but we need to understand something very important. I'm going to stop sharing. So the integral was, so the function, let me copy it, g of x equals negative x squared plus 5 and x less than or equal to 0, and x plus 5 for x greater than 0. Okay, so we're asked, the given interval is negative 2 comma 3. So we realize that this interval, negative 2 comma 3, is broken into two pieces. So let's say 0 is here. So between negative 2 and 0, I will have to use this function. And between 0 and 3, I will have to use this function. So if I'm asked to find the integral from negative 2 to 3 from g of x dx, I have to have a sum of two integrals, of course, with dx. The first integral will have limits of integration between negative 2 and 0, and the second one from 0 to 3. We haven't checked, but I'm going to check now. When I plug in 0 here, I get 5. When I plug in 0 here, I get 5. So the function is continuous. Okay, so the first piece will be from negative x squared plus 5. And the second piece between 0 and 3, when x is greater than 0, it will be from x plus 5. And now I proceed as we did all the time. So I have negative x to the third over 3 plus 5x from negative 2 to 0, and then plus x squared over 2 plus 5x from 0 to 3. From this moment on, the whole situation should be clear. I will just use the fundamental theorem of calculus and determine the value. It's nice when I have 0. I love it because when I plug in 0, everything is gone. When I plug in 0, everything is gone. So I only have to replace x by negative 2, but with minus in front. And I replace x by 3 here, and we're done. So my devices here are falling apart. Okay, stay in one place there. Okay, I'm on page 5. Yes. Okay, so here it is. When I plug in 0, I get 0. Just to be safe, I'm going to write it like that. Subtract. When I plug in negative 2, negative is outside. When I plug in negative 2 here, I get negative 8 divided by 3. When I plug in negative 2, I get negative 10. So this is... Say it again.
Oh, your camera turned on.
I'm sorry. Yeah, it's very sensitive, the hub that I have. Were you able to see what I just did? Should I repeat?
Oh yeah, it went dark right when you started writing the next page.
Oh, I'm so sorry. I touched the cable. I'm sorry. So, when I plug in 0, obviously I get 0. Minus, when I plug in -2, I copy the negative sign. I replace x by -2 and I get -8. 3 in the denominator. 5 times -2, -10. Plus, I plug in 3. 9/2 plus 15. Minus, but when I plug in 0, I will get 0. Finally, so this is positive 8/3 with minus in front. So negative 8/3 and then plus 10. Because -1 times -10 plus 9/2 plus 15. So negative 8/3 plus 9/2 plus 25. The least common denominator is 6. The top needs a 2, the top here needs a 3, and the top here needs a 6. So negative 16 plus 27 plus, I think this is 150. Yes. Okay. So 27 minus 16, I think that is 11. So this will be 161 divided by 6. Any questions? And that's the final. So notice what we did. We calculated a definite integral on a function that is a piecewise defined function. So the interval was given to us, of course, and we had to split the interval into 2 pieces because one piece was from a function and the other piece from a totally different function. So the situation was something like this. I'm not graphing that particular function. So let's say this and this. Okay? So the function changes, let's say at 4. And I want to determine the integral from 0 to 8. So this is function 1, let's call it f of x, and this is function g of x. So if I want to determine this area, I will have the integral from 0 to 4 from f of x dx, but the integral from 4 to 8 will be from g of x dx. And that's what we did, because this was a piecewise defined function. Okay, moving on. Are there any questions here? Is this okay? Is this understood?
Yeah, I had a question about if the interval is given in terms of e, or like e squared or something, like one of the numbers in the interval, should the final answer be given in e, or should you simplify it using
No, you have to keep e as is, unless we're talking about the cost or profit, in which I'm not going to tell you that I have in my pocket 3 e squared dollars. I will have to approximate. But if it's a nondescript integral like this, you know, there is nothing behind it in the sense of a real life situation, etc., etc., then I will leave it as exact as possible with e squared. But if we're talking about cost or profit or number of people, I'm not going to say that I have in my classroom 3 e squared people. Very good question. Anything else? Anything else? Okay, I would like to look at an average value of a function. So feel free, I'm going to share my screen. And feel free to choose, and then we'll come back to graphs and other situations in a minute. But I would like you to choose an average value, which I think is on the next. Right here. So anything from here, from 34 to 42, let's determine the average value of a function. Pick one, and then we'll go back to determining areas between curves or among curves. I'm ready. Which one?
Will we do 40?
Yes. Let's choose 40. Very